a web app. You get, at least for now, you can be able to build a web app. You can be able to build maybe a mobile app. You can be able to build a responsive app, okay? Whatever kind of app you can be able to do, application, that is the first thing. You have to be a developer, a software developer, which the first foundational courses, you learn Python, you learn web. Yeah, you need that knowledge when it comes to this module. You need all that knowledge combined together, because it's all about how you can use AI in software engineering. So as you develop a software, as you create the softwares, how can you use AI to enhance those softwares that solutions that you're gonna deliver? So let me, like I said, I promised to showcase, yes, to showcase something. Yeah? Cool. So this is the AI for software module, for software engineering module. Once it unlocks, it will look like this, basically. Yes, and the course core objectives is to make you understand core AI concepts, including machine learning, neural networks, and NLP. NLP stands for natural language processing, just in case it's the first time you've heard about it. Okay. Cool. And I'll be able to apply and to automate software tasks and enhance decision making and improve user experiences. You'll also be able to master the AI development workflow, from data collection to model deployment. You'll also be able to utilize popular AI tools and frameworks like TensorFlow, PyTorch, and Keras, plus many other more, yeah, that are not mentioned. Yes, cool. And then you'll be able to evaluate ethical implications and implement responsible AI practices. You'll be able to explore future of AI trends and their impact on software engineering. And finally, but not least, you'll be able to build a real-world AI project to demonstrate your skills and innovations. So that is what is expected of you in the course. Yeah, and this is how the course will be. The first topic is about introduction to AI. Then you learn more about core concepts of AI. AI in software engineering, that will be week 3. Week 4, you'll have development workflow. Week 5, tools and frameworks. Week 6, ethics in AI, or AI ethics. And then week 7, AI feature directions, and then week 8, your project. Now, around here, week 6, you see here, week 6, we will have finalized like the most important bits of AI, of the development part. And so from week 6, we expect you to be able to pitch your own project. You can now start working on your own project, AI project. Remember, since you chose the module, then we expect you that you will deliver a good AI enhanced project. Cool? Yes, so your project, your final project must showcase the use of AI. The use of AI, that is paramount. That is paramount. And remember, like I've said, by week 6, this is where we expect you to start delivering those projects so that they can be assessed. And then by week 8, you'll be finalizing. Okay, cool. So, meaning that will be week 16. Yes, ideally you are added 2 weeks for catch up, which is very good. Yes. Now, in the course of this, how are we gonna do this? Now, in the course of this, for example, after today's class, introduction, you see, this is a weekly learning. So there will be an assignment. Now that assignment should be tackled in groups, okay? So we will share a group. Evans, I think you can post it on the chat. Just post the group. We have a group for AI software engineering. You join that group. Evans will share that group link. Now, once you share, it's a WhatsApp group. Once you join the group, the first thing you should be able to do, because you guys you are brilliant. If you've chose AI, you must be very brilliant. Yes. Yeah, cool. So we expect you guys just organize yourself in 5 groups, in groups of 5, groups of 5. Okay. Now in those groups, those are the groups you will use. Choose a reader, choose everybody's role in the group. Yeah, the 5 of you, like one should be assuming the head of the group. Let's say it's like a company director, or director of the group. The other one should be, maybe you should have a secretary general, you should have a good maybe coder, AI engineer, who are the rest should maybe AI engineers. You get cool. So make sure you organize yourself so well. Organize yourself so well, so that in the long run, you can be able to tackle the assignments in groups. And then within the group, there will be, within the group, there will be a simple form shared. That form that will be shared will be to enable you to submit. Now, the group readers you choose, either whoever the group reader you choose, will submit your group name, because you should choose a group name and all the group members' names in that form. Okay. Yes. So once you join the group, that one will be done. Okay. Yes. I can see somebody saying share specialization form. My friend, what has been happening? You've not specialized, and this is a specialization module. It makes me wonder what's happening on the ground. Okay. Yes, because this is already a specialized module. So if you are here, I expect that you have already specialized, my friend. So yeah, so make sure well, the form will be shared in the group, but yeah, the specialization form Evans have already shared. It's there. Okay. So yeah, but it leaves me with a lot of questions. The meeting is being recorded, so worry not. So we are good. So that's said and done. That is how we'll be going. Those are just the cues of how we'll be doing the module. Okay, cool. I hope I'm loud and clear, hopefully. If I'm clear, just say it on the chat, clear. If that was clear. Okay. Yeah, if that was clear, just say it was clear. Good. I can see many people saying very clear. Nice. Nice, 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 nice. Beautiful, 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 beautiful. Okay, beautiful, beautiful. That's good. Thank you. So, that said and done. Yes, in AI, this one is something I have to tell you. In AI, you'll have, as we learn this, we'll have a lot of fun, because we are advanced coders. Now here, when it comes to AI, maybe you are considering yourself a newbie before this. Here now, we don't talk of newbies. We talk of AI engineers, okay? So from today, henceforth, count yourself as an AI engineer, because that's who you are. No longer is your name a newbie. No longer is your name some funny things, or a beginner, or sijui what, or no, I don't know, a beginner. Oh, no, 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 no. At this level, you are an AI engineer. No beginner, no newbie, no bond, no goating. It's those things that we don't do them here. Okay, cool. So AI engineer, that's your name. Cool, nice. Now, since you are an AI engineer, we'll be having fun. AI allows us to have fun, So in the course of the class, we'll be having some dance breaks. Why? Because when you dance, it helps you to relax and to refocus. Okay. Yes, it helps you to relax and refocus. Okay. Yes. So I don't know. I can ask for somebody to suggest which song do you think is the best for us to dance this morning? We want to have a dance break right away before we start. A dance break for AI engineers. Raho, somebody have suggested Raho, Wakairo, Raho, Christian vibe. Okay, I want to see many. Whoever comes more, the one voted most, that is the one we will do. Oh, Sinanoma, Waharo, Raho. Okay, I don't know what Raho means, but let's see. I think that's what has been Gospel 7. Okay, gospel vibes. All right. Gospel vibes. I think gospel vibes is coming a lot. Wakairo, Shusho. Okay. Wakario. Okay, whatever that means. Virvadi, Fos. Okay. Wakario. I think Wakairo, Wakiro. Okay, Wakairo, Zenzera. Okay, gospel vibes. Let's try gospel vibes. Let's try gospel vibes. Gospel vibes. So let me go with gospel vibes. Yeah, the other one will do. We have many sessions. So if you have suggested, worry not, we will dance all of them. We have several breakout sessions. So I've seen Wakairo, I've seen Lahore. So I think the next one will do Lahore, but let's start with gospel. Let me see whether we have anything gospel, piano, something like that. Cool. Yeah. Cool. Okay. All right. All right. So let's have a breakout dance for not less than 2 minutes. Let's go.
Okay, so you must say, come on. Can you feel it? Say, can you feel it? Yeah, bro. Can you feel it? Say, one time. Can you feel it? Say, come on. 1, 2, jump to that. 2, 3, 4, 5, go. Jump it out again. One more time. 1, 2, 3. Make it loud. Hands up. 1, 2, 3. Hey, all right. One more time. Everybody. 1, 2, 3. I have a very big God. Okay, let's go. Say it. A very big God. Oh. One more time. Say it. You know they for my hand. He's always on my side. One more time.
Cool. That was the first one. So the next one we might go Raho, Wakario. Yeah, I've seen those nice requests. Okay, that's the first dance break. And now after that, we'll delve into our presentation of the day. For those of you who have questions, by the end of the sessions, Evans will take all of your questions, okay? Yeah, these sessions have two parts. We have the presentation parts. I'll do the presentation. And then we'll have the demo part. Demo is where we'll create a simple chatbot, okay? Evans will take us through that. And after that, he will take all your queries. So feel good because you're in the right place. So if you have any query, reserve it at the end of the session. Shoot it to Evans and it will be well answered. Cool. So let's go ahead and delve into the presentation of the day. We want to know what is in it for us for AI for software engineering. So the best thing to start that is by asking ourselves, what is AI? Okay. Well, I know all of you guys have an idea what is AI. So the question is, into respect, in respect of what we are about to run. What is AI? Well, this presentation will be shared to you after class. It will be much available for all of you. So you should be able to get it, all right, after class. That is, it will be available to you. Cool. Nice. So let's delve into understanding what is AI. And basically, I know you have an idea. So in this overview, we will check on a few things like what is AI. We'll also check on a brief history of AI. We'll also check on major AI techniques, such as machine learning and deep learning, etc. We'll also check on how real-world applications and examples of real-world applications of AI technologies and ethical considerations and future trends of AI. We will look at that. Okay. So let's delve deep. So what is artificial intelligence? And I know you guys have an answer to that. I can see somebody, Gradis, have already said mimics human behavior. Maybe you can type on the chat. I want to see what you think. What is AI? Don't give me the ChatGPT definition. Give me your own definition, the way you understand it. Yeah. Just give me your own definition, like the one of Gradis. That one is not from ChatGPT. Don't give me a ChatGPT thing. Okay, cool. Making machine act like humans, Geoffrey. Making computers smarter, cool. George. Machine thinking for human, Mary Jenga, nice. Moses. AI is just machines working smart. Robots. AI runs from data. Ability for computer to mimic human. Cool. I'm loving it. Amos. It's a way computer think like human thinking. Machine learning to think as humans, and Keruja, Florence Kasembi. Hey, shout outs to Ponso, Florence, hey, Lucanyo, hey, okay. You guys, you got names, I have to say you're blessed when it comes to names. Man-made intelligence through AI, smart machines mimic human. Oh, good, you got. I'm grateful for you guys. Yeah, you are the best. At least you have an idea. So true to what you've said, that is AI. So basically, it's just simulation of human intelligence in machines. Yes. Just like the way humans beings are naturally intelligent, super intelligent beings. We can do a lot. Okay. For example, um, I'm sharing a presentation about AI. So I've organized a few things to make this happen, okay? There are a few things that I've done before we've come here. So the same way, we want AI or machines to be able, computers specifically here, to be able to help us achieve several tasks in automated mode. So if we have to do that, we have to teach computers how to do it and what we want them to do. Then we got to use some data, feed them data, and then make them learn how to do it, okay? And then once they do that, if they can be able to simulate it to some extent, yet with limitation of the data we've given it, then we can call that artificial intelligence. Because why is it artificial? It's limited to the data provided. Okay? Yes, that's cool. Now in artificial intelligence, we use two things that are very key. Okay? One, note it down, data quantity. So if you want a computer to do something, give it a lot of data about that thing you want to be done. Okay? Yes. We call that data quantity. That is, we say it's better to have more data than having less data, because the more computer data you provide for machines, the more they learn to be better. Okay? Cool. Then there's something else we call data quality. Now, quality refers to the correctness and accuracy of data. So you need very correct and accurate data for you to get the quality results if you want to have quality output. Because computers work on the same old metrics of jingle, garbage in, garbage out. So if you have the long data, definitely you'll get the long output. For example, if you wanted computer to cook ugali for you, ugali meal for lunch or fufu, then you have to give the correct ingredients and the correct procedure on how to cook and prepare ugali. Well, you give the long ingredients. For example, you say that the first ingredient to cook ugali you need is rice. And maybe you say the second ingredient you need is pork meat. You get? Well, definitely at the end of it, or you might not have ugali. You will eat something else, another meal. Okay? So if you don't give it the right data, then definitely you have the long output. We talk of garbage in, garbage out. So you've got to be sensitive of the data quantity. So you must have a lot of data. And two, you need what? Data quality. Observe data quality. Cool? I hope that point very clear. Yes, if it's clear, you can chat on the points clear. Yeah, clear on the chat. Just say clear. Clear. I'm happy. Yeah. Cool. Nice. Thank you. Nice. Good. So core tasks include learning, problem solving, perception, and language understanding. So in AI, you'll need to make a machine learn problem solving, like make the computer understand what the problem is, and then make the computer be able to perceive that problem in real world. Okay, like how that, basically, how does that problem affect real world? Cool. Like for example, if you are talking about hunger, tell the computer, give the computer data set about hunger. What is hunger? Okay, then make it understand why hunger is bad, all right, or is not good, or how hunger affects people, all right? Then we engage language understanding. That's where NLP comes in, natural language processing. Like you just process the natural language. You talk in your natural language, like the way I'm speaking in English, or natural, that's what we call natural language, or French, or Swahili, or Igbo, or Yoruba, or Karamajong. I don't know what is your native language. Maybe you can type down what's your native language. That's your natural language. The one that you call mother tongue. Yes. Yoruba, Luo, Shona, Masai, Pokomo, Ruya, Hindu, Karenjin, Tugen, Niwa. Wow. I didn't know Niwa. Circle. Okay, I didn't know that one. Kisi, Isizuru, Taita, Kikuyu, Kuria, Sapere, Sapere, Sambulu, okay, Luganda, Maragori. Yeah, those are natural languages. Scottish. Oh, we got somebody who is talk Scottish, and his name is Derek Owino. I see you. Okay, Scottish. All right, cool. Okay, all right. There's a language called Kasongo. I'm not sure. Turkish. Well and good. Yeah, cool. So that is, you should be able, that is, a good AI should be able to interact with its environment using the natural language. Yeah, yeah. So that is one. Okay, something else. Now let's give a good example. So very good example is Siri and Alexa. Maybe you're like, what's Alexa? Okay, I don't know. Maybe somebody can tell us what is Alexa. Alexa. And Alexa. Now, Alexa is what we call IoT, Internet of Things. So Alexa is a home management AI program. You can use for really working around a smart home. Yeah, it's a popular app for that. Okay. Yes. Somebody is also saying that Yusuf Aforabi is saying he's assistant for Samsung, where I don't know. Yes, I'm not very sure. The ones I'm referring to that virtual home assistant. Okay. Yes. Yes. All right. So that is that. Then so the way Siri is able to recognize your voice, you can talk to Siri if you're an Apple user or Alexa. They can be able to do natural language processing, okay? And you can interact with them. Cool. Then that one, the other one is recommendation systems such as Netflix and Amazon. For example, if you buy based on how you shop on Amazon, AI is able to identify your shopping skills or your shopping trends, and it's able to recommend item based on how you shop. Okay. Same as the way you watch movies on Netflix. So this is for those of you who have never seen an Alexa, the one that is saying good morning 6:30 a.m. That's what we call. That's what I was referring to. Okay. Yes, it's that system. Like I've said, it's a home management IoT. Jumia, Gigi, all those funny shopping places, they will look at your shopping trends and then they will recommend goods based on your shopping trends. It's AI that does that. Okay, cool. Yeah, and the same in social media. If you like, based on what you like and what you follow on social media, so many recommendations will be formed for you on social media platforms like Pinterest, X, Facebook, and what have you. Cool. Yes, the same way, if you do a Google search today, based on what you search, the more you search, once you open Google search, it will always give you relevant searches based on your searching trends. Cool. Yes. Where else do you think we apply AI? Hit the chat for text. Anywhere else you apply AI. Cool. Yes. Now, that is good. Yes, self-driving cars, good, cybersecurity, hospitals, customer service, everywhere. TikTok, yeah, everywhere. True, AI is applicable everywhere. I'm not very sure. How do you apply AI when going to the room? I have no idea. I got no idea. But I saw somebody, I know of somebody who carries their phone when they are going to the room. I tend to think they go to I don't know what they go to do with the phone. I'm still still searching. I'm still researching. But I know of someone who never, I don't know what they'd go to Google in the toilet. I have no idea. I don't expect guys to be Googling in the room, but they carry that. I don't know. But anyway, he's okay. I know someone who does that, but I'm still researching what they do. You know, I can't, I wish I could accompany them and go and check out. All right. So when did AI begin? Okay, guys, tell me, where do you think, how do you think, when did the AI begin? Um, which year? Just mention an year. I want to hear an year when at 2022. Oh, 1990, 1963, 2019, 1952, 1971, 1956, Kendo. Who's Kendo 1956? Okay, somebody said that Kendo 1956. 1952, 2012, 208, 2020, last year. Oh, okay. IBM was involved. Okay, 1956. Cool, cool. For those of you who have said 1956, clap to you. A clap to all of you who have said 1956. Yes, that's when the term AI was first coined. Yeah, in 1956. 1956, eh? So AI has been there as early from 1950s. Yeah, you thought it's an yesterday's invention. No, it's as early as 1950s. And the term AI, artificial intelligence, was first coined in a conference. Uh, yeah, where they were talking about, it was first coined about human mimicking technology. Cool. Yes, so 1956, that's the first time. So in the 1950s, that's when AI came around. So some of the timelines to highlight is that in the 1950s, we had the foundational theories and Alan Turing's, mostly the technology that was there was called Alan Turing test. Alan Turing is the guy who did the first test of training a machine how to run a game. Actually, he was training a machine how to play a game, okay? Which we call Turing test, okay? Yes, so, and it was successful. And then in early 60s and 70s, early experiments of what was called rule-based systems, okay? Yes. I don't want to defame anyone. Somebody, Macri and Grad, you are defaming someone. Why on earth should you say that? May the Lord have mercy on you. Okay. So early experiments, rule-based system. I think our chat today might be rule-based, or you one of the assignment. In your assignment today, you'll be asked to use rule-based. So you will know how rule-based works based on their today's assignment. Yeah. So yes, those were 1960s to 70s. In 1980s, that's when machine learning was introduced in in 1980s. Actually, 1982, I think so. Yeah, in 1982, that's when we got the first term, machine learning term coined. And then, yes, we have early 2000s to present, we've been having explosion of data computational power and deep learning. All right. Yes, that's pretty cool. So that is the history. At least now you know where AI started. Okay, cool. All right. So you might be asking yourself, uh, how many categories of AI do we have? Well, there are not many. We only have two. AI can be categorized into two or even more, but the primary is two, but we can advance to secondary, whereby we can say we have narrow and general, and then we have what we call super, super AI. That is part of secondary. You will learn once the LMS is open, you will learn why it's secondary. But In major, primarily we have two, narrow AI and general AI. So what is narrow AI? Narrow AI, the reason why it's called narrow is because it's designed for specific tasks, e.g., image recognition, language translation, speech synthesis. Yeah, cool. So if you have a speech synthesis program such as Siri, yeah, that is a narrow type of AI. Actually, all the AI you have seen so far so good is narrow AI. Okay. Then we have general AI. It is AI that aims to perform any intellectual task comparable to human, still theoretical. We will see why it's still theoretical in most. And some of the good examples of narrow AI are things like ChatGPT, DeepSeek, AlphaGo. AlphaGo is a type of AI that was taught back in the 80s, I think so, on how to play the Go game. All right. And it beat it performed so well that it out is an IBM based system. And it did outdo the current, in those days, the master of Go game. Yeah, the grandmaster of Go game. Yes. So it's a good one. It's narrow. General future goal of AI research. So far, so good. We have not implemented general AI, but we are still researching. Okay. Yes. So that's why I said primarily we have two major types of categories, narrow AI and general AI. The others you learn, they are all secondary, like super AI, super intelligent AI. You'll find it in your notes. Cool. That said, then we have machine learning. Maybe what's machine learning? Basically, it's data-driven approach where you train computers to run from data patterns. Okay, yeah, so it's a data-driven approach. Now, some of the key algorithms of machine learning include classification. Classification is basically categorizing or identifying items or objects by labeling. You know, say, for example, you see a cat. If you want to train a child, what's a cat? You show them a cat, okay? The same way, if you want your computer to run what's a cat, and you classify this is a cat and it's an animal, okay? Then you can show them this is a Volvo, it's a vehicle, you know? We call that classification, identification of various objects by using labels. Yeah. Then we have regression. Regression is application of linear algorithms. For example, where we could say A plus B is equal C. That's a linear regression. So regression is following algorithms. I think most of the mathematics teachers in Kenya, they don't know where mathematics is applied. I think that's a challenge we have, because I wish my mathematical teacher knew where to apply mathematics. They would have taught me that mathematics is very key in computing, okay? Unfortunately, I think they don't know, because in computing now, it really applies that X plus Y is equal Z, it really applies, it's practical. Okay, it's very practical. So all the mathematics you've ever learned, this is where they are applied. Mathematics like calculus, integration of functions, this is where they are all applied. Okay, yes. So if you're a fan of mathematics, welcome to the go. Well, you don't have to know mathematics for you to learn this, but it's good, you know, it's applied. It's pretty much applicable. Cool? Yes, probability, statistics, it's your applies here. And then we have clustering. Clustering is grouping of items that are of the same type. Okay, so for example, you can have cat A, cat B, cat C, cat D, they are all cats. That's clustering, okay? You group items of the same type together. We call that clustering. Hopefully that's very clear. Types of learning, we have supervised learning, that is use of labeled data, e.g. emails, spam detection. A good example is email spam detection. How is your email box able to identify that this email is a spam? It's simply because you've never received an email from it, or maybe it's a new email that is not relevant to any of your subject matters, okay, that you've ever communicated about. Cool. Then unsupervised, finding hidden patterns. So for example, if you wanted to know the types of customers you have in your shop, then you would like to know what kind of goods they buy, what time do they buy, and what time do I have more customers than maybe my customers come more in the morning or in the evening, you get? So such a kind whereby you don't have like clear data or clear labels of what to use, but you want to find some hidden patterns, okay? Like the buying power, you can check of purchasing power, you can check of things like their timings, because they are not related, okay? So we call that unsupervised learning. Oh, yeah, I hope you got that, okay? Yes, customer A might come to your shop and buy sugar. Customer B might come to your shop and buy a radio phone. Now, those are two different items. So there is no way you can group those two customers together. It would be very long. Okay, so you need to find different other patterns for you to connect those two customers. You get that? Nice. Very nice. So far, so good. I hope the going is good. Are you enjoying? Are you floating? Are you happy? Or are you, I don't know. Just let me know. Hopefully, you are happy. My hope is, hey, most people are happy. Cool, cool, cool. I'm also very happy. Okay, yeah. Somebody's saying, Gideon, you're saying I repeat supervised. I've said supervised, you use labeled data. Okay, like for example, you see you have a cat, you label that this is a cat. Okay, and you use labels, you append labels to items. Okay, yes. So that's what we call supervised. Unsupervised, and this supervised mostly happens when you are working with relatable items. Okay, but unsupervised works when you are working with things that are unrelated. So instead of labeling them, you have to find hidden patterns, okay, to connect. I hope that's very clear. And I've given an example of two customers. One customer walking into a shop, and then one buys sugar, another one buys a radio phone. Those two customers, you can't group them together because they've bought two different items and their needs are very different. So if you want to group them in, or if you want to relate them, you have to really find hidden patterns like their purchasing power. Maybe you check on their timings. When do they come to buy these items? Yeah. Cool. Nice. Now let's do something else now after that. We gotta check another type of learning you will learn is semi-supervised. Now, semi-supervised integrates these two, supervised learning and unsupervised learning. Reinforcement learning is very different from these three in that it doesn't concentrate on labeled or unlabeled data. It concentrates on rewarding a machine when it gets facts right. Okay, for example, a machine learns through trial and error. Trial and error. Yes, just like the way if you were to teach a baby how to walk, they will first rise up and fall, right? And then finally, they learn how to walk and they walk better, okay? The same way, if you want, this is the training that was given the AlphaGo. There was no labeling of what are the elements to use. It just learned from itself. It plays a game, it fails, it tries again, it wins one, loses like 5, like that, until it was able to beat the grandmaster. Okay, so we call that reinforcement learning. You award a system for, there is an award system, a reward system, whereby if the system gets output right, it's given a reward. If it's given, if it doesn't get it right, it's like given a negative reward. So positive reward for getting it right, negative rewards for getting it wrong. Yeah, all right, cool. That's where those type of rewards that are given, at times they are called tokens. You'll hear of the word tokenization. Okay, yes, cool. So far so good. Let's see what else we got. So what about, that was machine learning training. What about deep learning? What is deep learning? So deep learning, on the other hand, it's a subset of machine learning that uses neural networks with many layers. Maybe you are wondering, what's a neural network? The diagram just behind that on the background displayed an example of a neural network. It's a simulation of your brain. You know the way your brain works? That, for example, if somebody steps on your toe, there is a neuron that transfers that to your brain, okay? Yes, it sends a signal of pain to your brain, and then your brain registers you're feeling pain because the toe has been stepped on, okay? So that type of complex neurons system that works in a human system, it's simulated in deep learning. It's what is simulated in deep learning. And a good little world example is image and speech recognition, e.g. Google Photos and voice assistants. Yeah, they have to listen to your accent. They have to understand what language you are talking in, okay? Yes, so there is a lot of things that happen behind the image, behind the scene. So behind an image recognition, behind the voice recognition. Cool? Yes, and in self-driving cars, you realize that there is object detection that is involved. So a vehicle has to choose which is a corner, which is a roundabout, where is the traffic jam, such essentials for the self-driving car to be effective. So that we call that deep learning. Cool. Nice. Okay, now let's explore some of the AI concepts like natural language processing. One, it is a concept that enables machines to understand and generate human language. It's also good to know that chatbots, translation services, and sentiments are good showcase of applications of how we apply NLP. And a good example is ChatGPT or Google Translate. Nice. Cool. All right. Reinforcement learning. I think I've already talked about it, that agents learn by interacting with an environment through rewards and penalties. Good examples is AlphaGo, mastering the game of Go. Robotics, learning to navigate or manipulating objects. Cool. That seems very cool. Then let's see, some of the AI concepts still continued. Computer vision, a good overview. We have, what does it do? It enables machines to see and interpret visual data. For example, it is through computer vision that a computer can be able to know this is a road, this is a bump, these are traffic lights, these are pedestrians, and such. Cool. So that is computer vision. Just like the way you use your eyes to see, computer vision technology is the one that enables computer to see. So we use a modern technology called convolutional neural networks, CNN. Okay, you learn more about it as you continue. All right, so applications include facial recognition, how your phone identifies your face. For those of you who have face lock, it's very important. That's how you get to know more about facial recognition. It's through computer vision. Talk of autonomous vehicle detection, lane detection, how self-driving cars work. Yes, it's the same. They use computer vision. Now, another one is robotics and autonomous systems. Cool, robotics. Yeah, so robots are part of AI. And this is how they are integrated in that robots use AI to perform complex tasks in industrial automation, healthcare, and service robots. So basically, for a robot to have to work, mostly they use rule-based algorithms, or nowadays they use more complicated algorithms, such as regression, to work around issues or to work around tasks. Okay, cool. And if you go to the industry, for example, how your phone is made, there is no human involvement in making of phones mostly. It is all work by machine. All right. Yes. Google how phones are made or how computers are made. There is very little human work. It's all from beginning to the end is a machine work. Okay, cool. That's I hope you got that. Good examples include surgical robotics. So nowadays we have robots that can be able to perform surgery in clinic. Yes, so how are they able to do that? It's because they can be able to integrate AI, computer vision, and machine learning to note what to do to the patient. Warehouse automation, like those used in Amazon, they are very nice. They do very good work in stock identification and valuation. Cool. For those of you who might want to understand the warehouse automation, I recommend you watch a movie called The Forge. Yeah, in that movie is very interesting because at one point there is prayers made, and the prayers are made to revive robots. Okay, yeah, and miracles happen. A lot of miracles happen in that movie. You watch The Forge. It's a good movie for you guys. Yeah, you learn more about how robotics work in company. All right, that's good. Ethics and responsible AI. So when you are using AI, you have to be responsible of how it is used. Otherwise, you might abuse. If you don't use something in a nice way, as good as it is, for example, I hear somebody once told me that yeah, uh, it's good to have wine for digestion, okay? But if you consume a lot of wine for digestion, that is abuse of wine, you see? So you see that you get that concept, eh? Yeah. All right. I hope you get it. If you don't get it, forget about it. All right. But that's it. So as beautiful as something might be, if you overuse it, you abuse it. So AI is very good, but if you use it without considering the ethical part of it, you will abuse it and it will be bad for you. Okay, so to ensure that AI is responsible, we talk of responsible AI development. So we identify bias and fairness, ensuring equitable outcomes. So you want to implement AI without bias, all right? And also ensure that it gives you equitable outcomes. Cool. Also, you want AI to be transparent and explainable, making AI decisions understandable. That means the AI should be able to explain how it came to a conclusion. Okay, yes, it's good to have that. Cool. And privacy concerns and data protection. You should ensure that the data that you put in AI is well encrypted so that your AI model does not leak data to everyone who comes across it. Cool. So then we have a good real world context, case studies where biased training data led to unintended consequences. You can go and read about cases where, for example, there was one case where data corrected suggested that it was an employment gadgets in Amazon. So it suggested that for you to be employed, you had to be a male. It was female biased. So no, among the many CVs that were submitted, no female was taken because the data that was used to train a model about employment, it was biased against women. So plus many other cases that you can read about. Okay, cool. Now that is very good. And in the future, where do you expect to see the future of AI? One, in an industry, you want to see personal applications like virtual assistants, smart home devices, okay, like Alexa. Um, yes. Then you want to see personalized recommendations in streaming and shopping apps. Also, you want to see some emerging areas such as explainable AI, building trust through transparency, and also edge AI, processing data locally on devices for speed and privacy. This is like hosting AI locally on your device. Cool? Yes. That is pretty key. And finally, democratization of AI, whereby we have wider access of AI and open research. This is what has been happening from 2021. Democratization of AI by use of tools like ChatGPT, Gemini, DeepSeek, Grok, and many others like Turu. Yes, nice. I hope we're good. Now, it's good to understand the limitations of AI. AI is not everything, or it's not a solution to all problems. Okay? Yes. So it got its own limitations and challenges. One being data quality and availability issues. Not everybody can access AI. For you to access AI, mostly you need a computer and access to internet. So if you don't have those two, first you can't access it. You can't even use it. You might not even enjoy it. You might not even be aware of it. Okay. So for example, people who live in Eritrea, okay, those people, they don't have, you see that in Eritrea, AI is like internet, access to internet is limited to cybercafe only. So you cannot like have Wi-Fi the way you have home Wi-Fi. So those people cannot enjoy AI as much as they might want. Okay. Yes. So data quality, as I think I had explained before, that you need good data quantity and quality. I think I had done that. Then computational resources demand. AI uses a lot of resources. Okay. Yes. Um, Yeah, it is, AI uses a lot of computational resources. So it demands you to have a lot of processing power, computational power. AI will demand you to have what we call TPU. A TPU is a TensorFlow processing unit. Tensor processing unit is for processing tensor functions. You'll need GPUs, graphic processing units, and all those TPUs and GPUs are heavy, plus CPUs. They are heavy resource power users. Okay. Yes. So enjoying computational, if you don't have good computational power, you might not enjoy AI. Then adversarial attacks and cybersecurity concerns. Yeah, many people, you see, just like the way technology is advancing, also other bad technologies are advancing, like malware development. Do you have a malware developer in the house? Okay, okay. Just like the way you are busy studying software engineering, there's something else called malware engineering. Okay, so it's all about how you can develop viruses and malwares for systems. So also malware development. So a malware engineer can be able to like develop a malware that or a virus that can be able to attack AI technology. Yeah, and it can really do a lot of harm to the systems and the data that is involved. Cool. Yes. So yeah, you can specialize in malware engineering is a good thing, by the way, somehow. Yeah, it's only that when executed, it brings bad bad effects. Okay. Yes, we don't have malware engineering at PRP Academy. I'm not very sure. Very few. Maybe you can check what it. I'm not very sure whether Afrati offers. I think Afrati is the most advanced institution of technology in Kenya. I'm not very sure, but you can check. All right. So then there is human AI partnership. You see, AI is used by humans, and humans develop AIs for themselves. Okay. So AI is a tool, not a replacement for human innovation. So if you drive, when you first introduce AI issues, people think that AI is coming to replace them. No, AI is not replacing humans. It cannot actually. In the long run, it cannot. Okay? Yes. It is a tool because AI is a tool. It's like saying Jebez or combine harvesters will eliminate farmers. You see, that is not true. Okay. Yes, we need farmers who can control combine harvesters. Okay. Yeah, and it is farmers who can control combine harvesters who have more yields. You get? So the same way, it is a person who have AI, a software developer or any worker who have AI knowledge is better placed than a person who don't have. So guys, choosing this course, kudos. You get? Kudos. All right. Yes, that is great. All right, then there is some good examples, decision support systems in healthcare, creative copilots in design work. By the way, on 28th, coming Wednesday, we have a vibe coding, coffee and code at JQuat. I hope you guys will join, and I hope you've already registered. Yeah, you'll see how copilots are used in real time, solving real world solutions. Cool. See you there at JQuat. So time for Q&As. And first then we take a 2 minutes break, and then we come for the model with Evans will take us through how to model simple AI chatbot. Cool. That's very cool. Yes. Yeah, we have a song for the break. I saw Raho. I don't know what is Raho, but I'm gonna check it out for you now. I've never even listened to it, but it was mostly Raho. Okay. All right. So yeah. So guys, um, yes. Any question? Um, cool. Let's have Raho for a minute, then I will answer one question, and then Evans will take over. Okay, cool. So a minute, I set my things up. I'm cool. Um, yeah, cool. Okay. Is Raho? Yeah. Shari Pop with Raho. Cool. That was a dance break. I hope you've danced your way. So cool. I'll take two questions, just two. So for those who have raised their hands, I'll give you a chance to ask questions. Make sure you ask question based on the presentation we've just done. Okay. Any other question I said, we will reserve it at the end of the session with Evans. Evans will answer all your questions at the end of the session. So for now, we have to ask questions only related to the presentation. So Regina Abwana, you are allowed to talk. Regina? Regina, I think you are not talking. Millicent Anyango. Okay. Can see Mary Jenga saying that the presentation was very short. Oh, yeah, because I want you to have ample time to do the demo. Yeah, with Evans. Okay. And I think today we will be having two sessions. So we have this session, I think from now henceforth, okay, we'll be having two sessions, the morning sessions and the evening session. So we'll collapse them to two only, morning and evening. Yes, Millicent, you're not talking. Okay, Charles Moroy. If you raise your hand, make sure you have something to say. Yeah, okay. All right. Charles? Okay, Charles is not talking. Or I'm not audible. Chinedu? Yeah, okay. I think you guys, you have a lot of nothing to say, but your hands are up. Okay, so it's okay. Then I'll welcome,
Can you hear me?
you are Chinedu?
Yes.
Yes, Chinedu, I can hear you.
Yeah. Good morning, everyone. Thank you for this section. Um, are we going okay from the you said I know you said types of AI category that's supervised, unsupervised, semi-supervised, and then clusters. Are we going
Mhm.
to do all of this in our course? That's
Yes,
number one.
yes, that is
Then
very true. You will learn all of them, how to create a model that is supervised learning, using supervised learning, reinforcement, semi-supervised, all of them. You will learn all of them. Yeah.
okay. Then two. Well, that question is that some of us are new to this course. We've not really developed a full software from this because we've not integrated the back end and the front end. And you were mentioning that we have to be very good with that before coming to this place. So how can you help us with that?
No problem. You'll be like guided on how to do every program. Now, the way the course is arranged is like at the end of every lesson, you learn something, how to do something, okay? Something small, okay? So the more you learn, the more you bet, the better you become. You get that?
So because
Yes.
I noticed that it is integrated with software and we are
Yeah.
only going to
Yeah.
specialize on one, right? So is there any
Yes.
possibility of joining the software so that when you are asked to build a project, you know what to do, both the backend and how to integrate it? My suggestion.
You've already done the fundamentals of software development, true, of us?
Sure.
Yes. So those are the only things you need. That's
Okay.
knowledge
Okay.
is enough. Okay.
Okay. All right. Thank you
Yes.
very much. Thank you very much.
Welcome. All right. All right. I think that's good. Um, the last one, maybe you're ready. Millicent Anyango. Oh, Millicent is not talking. Then we can have Gladys.
Hello,
Hello, Gladys.
I'm good. I was just saying that the class is good and you're going on well. Congratulations.
Thank you, Gladys. Hey, that's a good vibe. Oh, nice. That's a good vibe. Girl. Thank you, Gladys. I feel happy for that.
Well,
So that's good. Let me welcome our 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 nice JS daddy. Yes, Evans, welcome. Take over.
All right, thank you, Takin. And I think you guys have enjoyed the session. So that was just the beginning. Maybe I also have a question to Takin. Takin, you said we are going to be having 2 sessions per day instead of 3.
Yeah.
Kindly repeat on that for some of us who have not maybe heard that.
Okay. So what I mean, previously we were having 3 sessions, okay, whereby we were learning the same thing. But since this is specialized, we see like we can have 2 major sessions instead of having 2 hours, 2 hours. Like you can see today, our session is going from 10 to 1. Those are 3 hours, okay? Meaning, instead of having 2 hour, 2 hour session, we can have this the same time, 6 hours, but now divided into 3 hour session, 3 hour session. That meaning in the morning, we have a class. Now we learn like we have done, okay? And we also get to do a practical together like we are going to do today with now Evans. And then um, In the evening, the same we will do, okay? But mostly we will embed on like even expanding more on the same concepts as well, so that you have double advantage, okay? Yes, and since now we are not as many as we were previously, so I think we can be able to handle 2 sessions per day. That looks more convenient to everyone. Good. I hope that's clear, Evans.
Yeah, yeah, that's clear to everyone. I just wanted you to bring to attention to that. So that means most of the evening sessions will be more of practical, getting our hands dirty and exploring all these tools.
Yes, true, 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 true.
All right. Thank you, Chakin. So I'll have a quick demo, and okay. So let me just boast a little bit. Recently, I did. Let me share my screen as I speak. So recently, I challenged myself to do 50 days of AI. Yes, before that, I was doing AI, I was automating my tools, I was doing my tasks, I was integrating tools with in my platforms, in my learning, and everywhere. But the moment that I decided to do 50 days of AI, that's when I learned we have so many things that we have to cover in AI. So that means in this course, you guys have to get serious, a little bit serious, a little bit committed to do that. So let me just show you something before I go to the demo. Something that I discovered. I doubted myself and then I discovered. I just discovered with my 8 GB of RAM and my 500 or 250 SSD machine, that is above Core i5 and 7, actually I can download a full model from Llama, open source Llama, then I can integrate or I can play around with these AI models. So I've heard about AI models. Actually, I can take this model, then I can create my own system using this open source model. So I don't have to source for data or those kind of things. I already have this model. Well, how cool is that? You can do that. You don't need a very, very big GPU and all those kind of things. You just need your machine and then you can run the basic AI tools. So quick fast to the demo. So Chakin was talking about, let me share the screen so that I can tell you where the demo is coming from. Based on the history and evolution of AI, the first foundational theories of AI began back in 1950s. Okay, all the way going from simple tests, training systems, up to where we are at this point, working with large sets of data. Now, we are going to begin from here, 1950s. After that, we are going to slowly expanding our systems and show you how behind the scenes, how these systems work. So I'm just going to have a quick demo, just explaining this code. How many lines? 27 lines of code, and I have a working chatbot. What is this chatbot basically doing? This is a rule-based system. How does it work? A quick overview. I define a function. Of course, this is a function, it's a class-based function, that is OP. Then I can call my function right here. Then I can execute all the tasks that I need. That is the overview. We can get into details now. So what I want a system where I can feed any kind of data. Now here comes, when you base that into the current evolution or the current advancement, you find that we have so many large sets of data in our machines or behind the scenes that we work with AI. So this is a simple set of data that I've loaded. Then I can ask my chatbot any question as long as I have that information right here. a simple demo. Then as we go on, we are going to incorporate more data, use AI models, then replace these with these models and the rest, the models that we are going to build, things like that. So what is this code doing? I define a class. Let me just zoom again so that you can see. So I define this class and I define a method right here. In this method here, oops, I'm going to pass a list of rules. What rules? For example, you can go to ChatGPT and say hi, and then it will give you a certain answer. That is a simple thing. Now, take this into large scales, like the data that is used to train AI, ChatGPT, and all those other big models. You have a list of highs. If you ask it this AI hi, based on different amounts of data that has been fed, it can give you hi, hello, how can I assist you today? Hello, how are you doing today? Hello, any kind of things, because we have so many ways of answering to this hi. That is one instance. Now, let's assume that I have constructed a sentence telling this AI, create for me a function in Python. Behind the scenes, we have a lot of data that has been fed, or a lot of information that we have in that model. So it goes and checks, do we have any forms of writing a function in Python? Then it will return that function that it defines behind the scenes. Okay? Then it will give you the answer. A different scenario. Of course, I think those scenarios are enough to explain what happens behind the scenes. So we have a question. Then we have a list of answers, possible answers that might have. So this chatbot is doing, we define a function, and in this function, we pass this method. We covered this in OP. So we pass a list of rules. For example, this is data. Hi, this is one answer that we can give, and we said we can give as many answers as possible so that it can fetch any random answer. I just feed a list of questions. What is your name? Something like that. And I can answer that question. Now, after you feed that information, if anyone asks any question that is available in our data set, then you can call a function here that is going to return the answer. So what is it going to do? I ask it hello. Goes here and fetches this function for a function, a method, this function for getting the message, the relevant message. So it will go into a list of messages. We can define a variable here, call it a message. Then we assign it to message. Then we format our text. When we are formatting our text, we'll tell it, fetch that anything into lowercase. Okay. So now here, the message that we have typed, like hello, what is your name? Help me write a function in Python. So we create a loop, a basic loop. What does a loop do? A loop will go through this list of questions, check what I've asked, if I can get a relevant information. So it will go through the system and find if I can get some relevant information based on what I've asked. Create a loop that is for a pattern. So you for pattern in self.rules. So we check any possible answer depending with our question, where from a list of rules. What are rules? Rules are the data that we have fed. It's the data that we have fed into our system. Okay? So in this system here, so if we find, so the first thing is going to do is going to loop through the questions. Then if we identify any pattern, in our message, so if we identify any pattern in our message, so what is the pattern? The pattern can be hi, hello, any question that we have asked. So the message, so the pattern in our message, then if we find any relatable pattern from our message, then it's going to do what? It's going to check through the list of rules, then it's going to return the relevant pattern or the relevant answer. At some point, you have asked ChatGPT a certain question, then it will tell you it has not found that information anywhere. So if we don't have any information related to what we have asked, then of course we write a return. Unfortunately, we can't find your message. We can't find what you are trying to look for or what you are trying to prompt. So that is the pattern. Before we go to this final step, I just want to repeat what happens here. So we have our function. Here, we set a list of rules, questions, and answers. We have said you can replace these answers with as many answers and questions as possible. How? For example, we can replace this later once we understand the basics, we replace this information, we replace this with the actual models like this llama, these llama models that we have here. They are only 3 to 4 GB, depending with the size of the model that the parameters that you have downloaded. So we are going to replace this with the actual information. So then we create the response here. For the response, we check our question. Of course, here we are trying to format so that we avoid some error messages that we can have. So whenever you are typing, you type everything and appears in lowercase. So we look through our list of patterns. So we create a pattern here. It's just like creating a variable pattern. Then you look through the list of rules. So if it identifies any pattern or it identifies any question that you have asked, then it will go check in the rules, then it will return the pattern or it will return the relevant answer based on your question. Where are the questions? Remember, we have fed our data here. Up to there, we are good. And of course, if you have created a function, doesn't matter if it's a OP based or it's a normal function or programming, you have to call that function. Now, we can call our function right here. Let's define a variable that is called chatbot here. In this chatbot, now we call our function or our class that we just defined right here. So let's go back to OP. OP, we said we have different ways of writing the same thing. Instead of writing the normal function, this is a normal function. You can replace that with OP based. So this is object oriented. It's another way of writing a function. This is called functional programming. This is object oriented programming. Now, so chatbot here, we define this variable that is going to call our chatbot. In ChatGPT, for example, here, let me show you what we are trying to implement. If I go to ChatGPT, for example, I have this input. So in this input, I'll say hello, right? I'll write hello. So this is what we are trying to implement right here. While we have some inputs, so while true. So this one, we don't expect any ChatGPT here to give us any information without us asking a question. So this input field should be true. We should have something right there. So this is our input field. Input field, just input your question. After you input your question, if we have any input if you have any input, and of course that has been formatted to lowercase, then if our input is not exit or quit, then it will print you goodbye or something else. If the input field is not quit or exit, it will tell you goodbye. Do you have any other questions? Something like that. Then, of course, if our text is not exit or quit, then the chatbot is going to do, it's going to call this function that we implemented right here. Then it's going to get this method that we wrote here for giving us the output. Then it's going to print out our output as expected. Let me explain again from top so that we try it. We write a class here. We set a bunch of rules, or we load with a lot of data here. Here, we define the response. So this is going to evaluate, or this method is going to evaluate our question. What is the type of question that we have asked? Then it's going to loop through these questions. And if it defines any relevant answer for that question, it's going to return the answer. Of course, we define a variable here that we assign to all these. But there's one step that is remaining, the input. So while is true, if our condition evaluates to true, what condition? If our input asks any question, then print out the relevant information. Very simple. So I want to try something in ChatGPT and show you what is exit and something like this. You see this button here, it's telling me to quit, to stop. So this button that was here like hello, then I try to submit, and this button here should tell me to stop asking the question. So that button here, we have simulated it with exit because we are yet to implement such a thing. So if our input is not exit or quit, then give us a relevant answer. So that's basically what we have implemented here. So can we try it out? Then just a moment, cd chatbot here. Then I can run python index.py. So if I ask any questions like hi, then the chatbot will respond, hello, how can I assist you today? Then I can ask question, who are you? Maybe I don't know if we have that answer at that question. So I'm not sure how to respond to that. So I can try, you can try ask help. Why? Because our data that we have fed here does not contain anything related to that. Okay? So if that information was there, then the input should give us a relevant answer. Basically, that's how these chatbots work. To explain it again, just the last time. Now, this here, according to ChatGPT, according to those input models that we have been using, chatbots, so we have a lot of data that has been fed in this. Then if you have asked any question, it will go through this list of questions and answers that have ever been asked and how they have been answered. Then it will give you the output. So basically, that's how these chatbots work. So this is a rule-based chatbot. Later, we are going to replace now this data with actual models that we have, like 1,000,000 parameters, 1,000,000,000 parameters, depending on the model that we are going to be using. Then if you replace this with a range of questions and answers, then that means we are going to get a relevant chat bot with AI. And imagine that's how AI began with setting up these simple things, later evolving to bigger things, loading with a lot of data and a lot of information. Yeah, so that's for our basic demo. Do we have any question, or Chakin, do you have anything to say according to this demo? Imagine AI is not that hard, guys. It's that simple. Now, someone is saying things I love seeing. Yeah, of course. So I can answer some few questions. Is it possible to create your own chat from scratch without borrowed models? If you have any data, yes, you can create your own chatbot. So AI is all about data and all about information. Can we have the repo? Yeah, the repo is right here. Let me just share the repo. I think I had created this repo. The repo is right here, and it will be shared on your WhatsApp groups. I've also shared it in your WhatsApp, so you can check that. Someone is saying that they feel like they are Sam Altman. Ah, of course, you can even be the Kenyan government. Okay, can a data be a file while creating a bot like the text file? Yeah, of course. You remember what we did when it came to what we call it, file handling in Python. Now, instead of defining your data right here in your code, because you're going to have a lot of data, of course, now you can implement this with the file handling. Then you just import the file right here. Then if you have a file like this with a lot of data, like a txt file, then you can get your relevant output. Someone was thinking, if you were thinking that building these AI tools is very hard, then you are wrong. How do you deploy these kind of things when it comes to AI? How do you deploy it? How do you deploy? We have so many places that you can deploy. You can deploy on Render, GitHub. You can deploy in so many places. Can we use API key? Yeah, of course you can use API key. Now, the reason why you need to use API key is, for example, if I don't want to download this big data and load it into my machine, then that means I need to look for where I can get API key. For example, you can get API key in developers like developer.openai. Let me see if I can get the OpenAI. Not developer, but platform. You can get your ChatGPT API right here from, then you use that as your data source. Let me just share the link to where you can get similar API keys. How do they update chatbots with data such that they can respond to many questions? So updating this data, if you collect the data, maybe you can collect a list of questions, how people ask questions on the internet, then you just come and upload your data, for example, right here. Then it's going to handle those different questions. We say the AI, if you hear we have a billion parameters and billion things here and millions of data that has been loaded, then that means this text is a lot of text that has been loaded to this AI, then we get the output. In my 50 days AI challenge, what website was I using? I was using a lot of website, of course. I was using ChatGPT AI documentation. Of course, I was using the Gemini AI documentation and watching a lot of videos and doing a lot of practicals and a lot of trial and errors. Can we use PHP language? Of course. For example, the AI things that I was working on, they are all JavaScript based. So I did a lot of research how you can use AI with JavaScript, and then I got you can do AI with any language. But for now, we are going to be using Python because Python is mostly used for the backend design of these chatbots. How do they enable AI to search information from the internet? So over the internet, we have a lot of API keys. So in these API keys, they feed our AI with this kind of data, right? So let's say we feed a list of API keys. So in case you can be API keys, can be website links, can be anything. So if you feed, let's say, a list of websites here with different informations. For example, I have a website where I teach people or I write blogs on how to do certain things. You might find that in one of my blogs I have, then we have information. So what it does, you define rules. What kind of rules do you define? You define and use things like use the request library. We did libraries in Python. We use the request library. So the request is going to do what? The request is going to go to that website, then scrap all the information or try to read through the information of the website. Then if it gets any relevant information anyone has ever asked, or any relevant information depending on whatever you have asked, then it will fetch the information from that website, then it will return that output to the relevant user. So basically that's how they access information from different websites. What is that we have said we download? I've not said we download anything, but in case you want to get a lot and a lot and a lot of data or a lot of information or models, then you can download, for example, this open source Llama AI models and these big and big information of data. What exactly do you want me to try? That is Oliver. You can just describe your text, what you want me to try. I share the code. The code is right here. Let me see. I shared the code, GitHub. Yeah, there we go. There you go. The code. I've shared the repo of this basic chatbot. So for people who are saying that we API keys, of course, we are going to try these API keys. Most are open, but you are given tokens that you are going to be using. So never worry. Along the way, we are going to show you how you use these different API keys to fetch data with AI and these OpenAI API keys. Don't worry. We are going to be there. So I'm trying to see all the relevant questions so that I answer. So for the API keys, we are going to show you. Don't worry, guys. Which models do you recommend that we download? You can check the Llama, that is the Llama AI. For example, you can download this lightweight model here with only with this version 3, 1 billion parameters. It's too light. It's too light. Your machine can handle this pressure. Yeah, you can check the Hugging Face. You can check the Hugging Face. We have a list and tons of these models that you guys can download and try them out. Showing you about the API, of course, we are going to show you. Never worry, never worry. It's day one. We say day one should be one. So someone is saying ChatGPT can make mistakes. You mean there is no way that developers can work to solve this? The only way that developers can work to solve this, it's just to load the AI tools or the AI models with the relevant information. So if you load these AI tools with the relevant information, then that means these AI tools are going to avoid these small mistakes that we get. So someone is asking, how does AI generate example new songs lyrics? So this is what happens in the background. We already have cloned voices. People who have uploaded, now you see we upload in normal text. There is another way you can upload images. Another way you can upload sounds. Okay. So sounds will upload what kind of a sound? Is it a speaking sound? Is it a singing sound? And what kind of singing? Is it a rap? Is it slow like reggae? Is it something like a mapiano? That tone they use to make um, those different musics. So you load all these kind of sounds and lyrics and flow into a model. Now, once you load all this information, now you have to get text. Whatever they are speaking or whatever these guys speak and how they compose this information, then you get that text. If I tell my AI to create a rap song on a certain thing, so it will go and take the voice. Then it will list of text. Remember that we have billions and billions of text. So in that billions and billions of text, it will combine all relevant text based with whatever uh, you have asked. Then it will combine the sound, and then the sound will read or will try to read the information in that text. Then with that, it will have composed the song that you are talking about, or the question or the song that you wanted to do. Is it a song? Is it a sound? Is it a podcast? Is it a speech? Now, someone is asking, how is Llama model useful? Llama model is useful in this way. You see this code that we have written here. How many lines of code? 1, 2, 3, 4, 5, 6. These are only 6 questions, right? These are only 6 questions. Now, the Llama model, that means, first of all, we have a lot of information, a lot of data, a lot of these rules and parameters right here. Billions and billions of text. So Llama model basically gives you that kind of text and information in large quantities. Then all these models have basically been trained. We are going to get into data training and this training these AI models to do whatever we want them to do. We are going to train them. We are going to show you how you train them. Then those models are already trained. So the moment you're asking it a question, hello, based on the information that it has been given, it has been trained on how to answer a law. So basically, what is training? So that model, like the llama, we have the model, the data, and of course, some of them have been trained. Some of them have been trained to answer these questions. So on your case, if you are using the llama and all those other or llama Hugging Face, that means you get the data and the data that has been trained with the relevant information. So you are avoiding the hassle of sourcing for your own data and training the models. Basically, that's what these models will help you do or will help you crack and avoid that big hassle. Okay, any other question? Any other question? Waiting for your questions. So what is the difference between normal data and trained data? Trained data, of course, trained data gives you relevant answers. Let's say you ask it a law, it already knows how to answer a law. It will check a list of questions that have a law and then it will give you an answer. Untrained data, that means it's just like our raw data right here. So this raw data cannot be accurate, that most accurate when it comes to giving us relevant information. You might ask it a law, and at some point, because we have a lot of questions and a lot of data, it might hallucinate, it might answer something else. For example, just like human beings, AI mimics human beings. You have been trained all the way from your kindergarten to where you are on how to answer hello world, like hello, hi, how are you doing today? You have been trained on how to answer that in different ways, depending with who is asking and where you are at that point. So you have been trained on how to do that. Assume that you have not been trained on how to answer based on where you are. You can be asked hi, then instead of saying hi, how are you doing? You can say, sure, I can help you do that. Instead of answering the hi. So basically training, it gives you more relevant information without hallucinating on what to say. So basically that is the basic difference between trained and untrained data and information. Can you use AI to train another AI? Of course, you can use AI to train another AI. And we are going to implement that to see how we can use models and machine learning to do all that task. Can we have AI model that is focused on specific data? For example, a bot that only teaches and assists in mathematics, like maths-based prompts or queries. Yeah, of course. How do you come up with that? Let's say we are collecting our information to give our AI. A basic example. So you go collect all data that has mathematics, then you feed it there. Then the questions that you are going to ask and get answers, they are only mathematical information. That's one way. The other way, you feed a lot of data or a lot of information, then you use machine learning, then it will figure out for itself. I can restrict, I can write rules, only answer questions that are related to mathematics. So, of course, when I'm asking any question that is related to mathematics, then that means I'm going to use mathematical terms. So if my chatbot sees these kind of terms, then it's going to fetch all the relevant information that is to do with mathematics, then it's going to give me certain information. So this is AI model that you have trained it to answer specific questions depending with certain data that you have given it. So that's how you will basically come up with models that are trained to do specific tasks. For example, let's say the Tesla model, the Tesla cars and those AI powered cars, self-driving cars. So mostly they are fed with traffic light data, how people behave on roads, different Google Maps. So basically you are training that AI on that aspect where you are feeding it information on that certain field. So the moment it sees anything similar to what you have trained it or similar to what data you have provided, then that means it's going to only do that kind of task best because you have given it the relevant data or the relevant information. Can we have AI that focuses on analyzing data? Yeah, of course. Of course, you can have it. We can have it. So let's say you have trained more than two responses to a question. Hello, what will happen to responses on those responses will be provided? So basically we do this. In programming, we have looping. So it's going to loop, check your question and loop through relevant answers. Then it's going to take one of the answers, then it's going to give you that answer. So you have seen, for example, when you ask ChatGPT, like create a basic Python function. Let's see. Create a basic Python function. So it's going to search through the data that has been provided, then it's going to create this simple function. Let's say I ask it the same question. I ask it the same question. Let's see what it's going to give us. You see? So it has gone to the data, then searched the kind of information we have all about functions. Then it looked through and gave us our first output. I asked it the same question. Then it looped, then gave us a random answer. Now you can do reinforcement. For example, reinforcement like, if I ask it the same question, it gives me the first answer after looping all through. Then I reinforce it. I tell it, if according to my input and output you have provided similar information, do this. Don't give me the same information. Give me a different answer. So you are reinforcing it not to give you the same answer. If it defines the answer, then you reinforce it to tell me, give me a different option or a different solution. Basically, if you feed information, then that means it's going to loop through, then it's going to give you a different answer every single time. So how do I handle errors like example, say, instead of hello, it will interpret hello. I've not understood your question. So how do you want it to interpret the hello? So similar question to AI, that teaches maths. How do you making an AI that uses other existing softwares to edit video or even mixing music to balance the songs clear, something like that. Now, I've told you, AI that does maths, you feed it with relevant information about maths. Or you create rules that restrict it to only answer maths questions. Same case happens to video editing and all those kind of things. For example, how many videos do we have in YouTube about video editing? So many, right? Now, you feed AI with certain information. How are people editing? How are people playing music? How are people mixing or DJing music? Then it will combine different musics. Then it will go through or look through this list of um, mixes. Then automatically it will replicate or it will mimic the same behavior that you did. Then it will mix the music or it will edit these videos. So for example, for video editing, what it will do, it will check the video that you have uploaded. Then of course it has been optimized to do the best. So it will check the best position that we are sitting or the angle that you took the video in. Then it will try to read all the content of that video, sound, everything. So after it reads the sound, then it tries to understand the flow according to a perfect English or writing sentences and paragraphs. How can I best frame this video? I create a storyline, then I try editing my clips, then fitting that certain criteria. Then you find your video has a certain best flow. So it basically chops your videos into those segments, then it understands and then combines them, then does the editing and the rest. So basically it reads the content of your video, then it goes to its algorithm, then checks how can we how can I best edit your video? Then it does the editing itself. Someone is asking, can we use the models offline? Yeah, that's why I downloaded the Llama model to use it offline. You can use these models offline. Okay, another question. Since we'll be using data sets to train AI, as the process with our machines, we'll be able, let me see the question. So we'll be able to manage the tasks. Yeah, we are going to manage the task. Remember, the task that we are going to be doing, it's going to be depending the amount of data that we load into our machines. So if we load a lot of information, then our machines are going to require so much space and so much GPUs and CPUs. So because our task is not heavy, it's not going to be used by so many people. For example, I gave you these examples of the Llama, blah, blah, blah. You find these models is only 6, 7 GB. They're simple. And we have billions and millions of text. So that means the machines that we have, they are going to be handling most of these tasks that we have. Yeah, never worry. Your machine is going to be handling the data sets that we have. How do we handle the models in your code? How do we call the models? We are going to show you. Never worry, never worry. We just want to make sure the beginners are in a safe space. I think, yeah, I said the lightweight models. The lightweight models only like, for example, what I mean by lightweight, you find only this is text, raw text, and text is light. It's not combined with things like the images, like the text, and all those heavy tasks. So it's just a lightweight version. What would be a good chatbot project for beginners? A good chatbot, for example, for beginners can be a medicine, such kind of a thing, application, where maybe I'm suffering from headache and I clearly understand what type of headache I have. For example, this headache is focusing more on my forehead, depending with what I am hearing and what I can describe as a human being. So I can ask this chatbot, what kind of problem am I suffering because I have this certain type of headache? Then it's going to give me the kind of headache I'm suffering and the medications that I can take. So that means you're going to feed information. If I have this headache focusing on this part of my body or my head, then this is this kind of headache and what are the recommended solutions I can take and what are some of the recommended solutions that I can take to solve my headache. So that would be a good chatbot project for beginners. Hope you'll take it slow. Of course, we are going to take it slow. That's why you are seeing that I'm trying to avoid how to integrate these models and also using API keys at this stage. That's why you see I'm trying my best to avoid that. How are chatbot implemented to be used by non-coders? The chatbots to be implemented by, so the of course the developers, they do the dirty work like this. And of course after here I'm going to create a UI and we have, is it open UI? What do we call it? I'm forgetting the UI that you can use to integrate with your chatbots. I think I'm forgetting the UI name. It's a website where you can download the UI. Then it's just like integrating this front end and back end. And I think I've answered most of your. Yes, we have this MGX. I've seen Philip. You can research. I don't remember it on top of my head. Yeah, the Streamlight. The Streamlight. I think OpenUI, something like that. Will you be taught on how to integrate the UI? Of course, we are going to show you how to integrate with UI. So someone is asking, how do AI companies really make money? For example, how can you make money with AI? First of all, there are so many ways I can make money with AI. Let's say you people are coming to us. Let's say, for example, let's say if ChatGPT was mine, if you haven't asked any question here, of course, this is a tool that everyone would like to use. So you'll find most of you guys would like to pay to get extra features. So I'll pay. I'll make money in that one way. Otherwise, this is a helpful tool. I can collaborate with people, different people do philanthropy, then they can donate money for me to make money and hire more people and do that. So there are so many ways that these AI companies make money. At this stage, most of the companies, they make money through funding. So if people give you money, you go and build these sophisticated tools to buy data and all those kind of things. So basically that's it for today. I've shared the repo. Let me reshare the repo. Let me reshare the repo again. You can clone that repo, you can fork that repo so that whenever we update it, you guys will be able to see whatever updates we have made for a certain class. So that's the repo that we are going to be using all through from lesson 1 all the way to the final lesson. The same repo, updating it. Yeah. Thank you guys. I hope you learned something. I hope you're excited for the next steps. The next session will be the evening session, and the evening session will be more of practicals. So, all right, thank you. I hope you enjoyed. I hope you learned. See you in the next session.